Well, I found another Kim LED array streetlights in the skip. Not sure if it works, but yeah, doesn't look damaged. Lucky, because it was laying this side up, so it easily could have smashed some glass or steel. Could have smashed the glass window. So let's see. I'll open this device up, see if I can have a look inside. See. Have a look at the wiring. Hang on, I'll put you down in a sec. The ballast looks in a lot better condition than the other Kim we had. 150 watts. The wiring looks all intact. Let's have a look here. Oh, there we go. It's connected, disconnected. White one, black one. Photocell has been isolated. Earth is on. I'm going to connect the device up and see if I get any response. Well, I got rid of the photocell wiring, and I see here in purple and a grey wire, and it says optional dimming, do not discard, so that is going into the device here, so that can get pulsed or something. Leave that away. It's important with metal cased appliances like this. This is a class 1 appliance, so it needs to be earthed. So I put an earth wire on here. It's pretty Mickey Mouse, but that's the supply coming here. Active is brown, light blue is neutral, and yellow green. That goes to the earth. That's on the metal work. Then light blue, American white is neutral, and you'll see they put some black tape on here, so that is the neutral. Black is active in America, so brown goes to that. And I've got a meter on here, and I've got a plug around here, and we're going to put it in a receptacle and see what happens. Okay, energize device. Oh shit, it works. That's amazing. Didn't expect that. That is pretty bright too. Wow. That is pretty bright. Yeah, camera doesn't do it justice, but it's quite bright. I've got it here on a current sensing device with a Hora water. I'm going to tidy this wiring up briefly, and then let's do a load check on this device and see how it goes for a while. I'll hang this here for now. Oh, that's okay. Yeah, the meter is turning 49.1. Here the light is bright. Beautiful. This is a reading on this device. This meter. The meter reads for a program for 300 to 5, but this meter gives me power factor, which is quite good. So the readings are 60 times too high, so I'll go to the other ones. Data still. CT ratio 300 to 5 is what the meter says. Now we're going to the engineering mode. Consumer section, so we go through all these steps. There's heaps of life still. Reactive power. The best part is it gives me a power factor reading. Phase failure, it's correct, only running one phase. So that is, what's that, 232. These phases are disconnected. Phase A, currents 33 amps, well 300 to 5, so that's half an amp. I need to divide it by 60. And it's power factor 0.99. System power factor, that's calculating 0.99. So this street light has almost unity power factor. That's pretty good. I know they got a capacitor in here. I think this device, I haven't had a close look at it yet, but this is, I think, the power factor device here. So this ballast here does a pretty good job in coordination with the inductor or whatever thing they got in here. So we'll let this cook for a while. 49.14, so that's advancing slowly. And I've got a Hora water here. They give me the running hours. Okay, get a good reading on this device, 14600. Can't see the bad decimals to the camera, 0.9 I think. So we'll let that percolate away, and I'll keep you guys posted. So the skim lamp has been going for 24 hours more or less, and used just over a kilowatt hour of electricity, which is fine. I'm just going to expand out a bit on the dimming function on the device. Well, when a multimeter is on ohms, it will put out a voltage here, and that's the dimming wires on this lamp, and there should be between 0 and 10 volts DC as per label here. Just have a look here on this thing here. Volts positive, purple or violet, and grey is negative. So I'll just poke these wires in here briefly, and I notice the lamp's reducing brightness. So this is probably only a couple of volts, so I'll see if I can demonstrate it here. Yeah, I'll put these wires in here and see if we get a reduction in brightness. I think we do. It does reduce. I'll just put the polarity the other way. I'm not sure where it's supposed to go. This is just by the ohm meter. So the dimming option appears to work quite nice. So you have to apply a voltage on the device, but you just can put a resistor across the terminals. So the open circuit of the control wire is 10 volts, and by reducing it you can just play around with the adjustability of the device, which is quite cool. Here we got the current at the dim position and at full brightness. This thing about half an amp, and when we dim it, I'll just dim it with a 220 ohm resistor, going down to 0.1. There we have the resistor and the dimming wires, and I just control it from here. The other interesting part is that the power factor is dropping quite a lot. Power factor dropped down to 0.7. So on this meter it was 33, now it's 6.4, so that is with that CT ratio. 0.7, and we go on full power, then we're back to 0.99, so it creates a phase shift. May hook the oscilloscope up, we'll see what happens. Watch the meter speed, disk speed. It's definitely faster, so yeah, we're going down to about a quarter of the current. Just to expand, with that 220 ohm resistor, the voltage across that terminal for the dimming appears to be about 0.5 volts. We'll take the control off, it shoots up to like 11 volts, and we got full brightness. Put it back on, and it goes back to about half a volt. I'm going to put a pot meter on there actually, that makes sense. So it's quite cool to have a dimming option on one of these lights. Now put it up, put questions in, and I'm going to test the dimming option on some other straight light devices as well. It's yeah, R&D. Thanks for watching. Final reading at this stage at low dim is 52.2 kilowatt hour.